This video is about closure properties of regular languages. Closure properties. And what we are looking at is what automata can do. So we're considering what NFAs or DFAs can actually do. The idea is starting with one or more automata. So assume we have some automata, let's say automata here, something like this. And we have more, another one. And you take these automata and put them into an algorithm, a systematic construction. We want to devise systematic constructions and these systematic constructions, they should yield new automata. So the result should be another automaton, like this one maybe. That's the idea. And what we are going to look at in the following videos is how to actually make these constructions. And the properties we are going to look at, properties. The first property is union. It's called union because it's the construction of an automaton accepting the union of the languages accepted by the input automata. This is something that's very typical and practical. For example, if you look at a password policy, you might want to have a policy requiring, let's say, numbers or special characters. So if you have this kind of OR idea, then you end up with a union. So you might have special characters or numbers. That's the union case. We'll also look at difference. Difference or complement. That's something like you don't want malicious characters in the input string. For example, if you have a website, you don't want the user to be able to enter malicious code. So no malicious characters. The next thing is if we have union and difference, we might want to have intersection. Union is the OR and intersection is AND. So we have the AND idea. Maybe we would require certain length and special characters. And special characters. These are the set-theoretic properties. There are also more language-specific properties like concatenation. Concatenation arises typically, for example, in addresses. You start with a number and after that you have the street. Or in the German version, you first have the street followed by a number. That's the typical case for concatenation. And there's also star if you want to have an arbitrary concatenation of words of the same language. And actually, the regular languages, they're closed under all these properties. Now, why is it called closure properties? The idea is that a set is closed under a property if you take two elements from this set, combine them with this operation, and the result is still in the set. Example you might all know is that the natural numbers are closed under addition. If you have two natural numbers and you compute the sum, the result is still a natural number. They are not closed under division. If you divide one natural number by another natural number, it might be that the result is not a natural number. If you divide 1 by 2, for example, the result is a half, which is not a natural number. So natural numbers are closed under addition, but not under division. Here, the regular languages, they are closed under all these properties and much more. And in the following videos, we'll have a look at each of the properties and how to actually construct new automata from given automata to get an automaton for this property, for this operation.